for the talk, which would be titled Hot Dip Galvanizing, a Long-Term Investment in the Built Environment by Fabio Pasquale Permana. For Mr. Permana, the time and stage is yours.
Thank you. Good morning, everyone, and good afternoon in Indonesia. My name is Fabio Pascal Permana, and I'm currently an apprentice by Zinc Power, in a company that specializes in hot dip galvanizing. You see, what is hot dip galvanizing? No one really knows what hot dip galvanizing is. Maybe from the memes, or maybe from the jokes, or maybe from a presentation from someone else, or maybe it's practically everywhere. It's in the built environment. But why hot dip galvanizing? Because hot dip galvanizing is a process where we coat the steel layer with a coating of zinc that make it last longer and longer and longer. Usually it lasts at least 30 to 40 years before it starts to degrade. And that is practically what my abstract is. Next. So steel is essential for construction, but it contributes significantly to carbon emission. But hot dip galvanizing is a sustainable practice on reducing carbon emissions. There are 3 important points. The first one is to show the effectiveness at extending the lifestyle of steel. And the second one is to measure how it can help cut down carbon emissions. And the third one is practically to address the challenges faced by the industry. Next. So for the research, I use 2 types of research methodology, quality and quantity, whereas we can see the finding implications that we could see in the built environment. Next. So this is the key findings on my research. There are 3 types of steel. The one that have no coating, the one that is painted, and the other one that is hot dip galvanized. From the durability, we could always see that the no coating is very vulnerable to rust and corrosion, because steel, it actually degrades quite fast. But with a paint coating, it will be still susceptible to damage. And it is not as thick as hot dip galvanizing. And the third one is hot dip galvanizing. Excellent corrosion resistance. Why? But why? Because with hot dip galvanizing, it has a layer that actually could heal itself from the steel. Because even if it corrodes in a bit, and a bit, and a bit, it will still not degrade as fast as paint coating. And with the maintenance is also quite important, because with no coating, it needs to be repaired as often, because we need to be replaced again and then make another steel and such and such. And with the paint coating, it needs to be cleaned and it needs to be touched up each and every, usually around 3 to 5 years. For example, if you say in Indonesia, there's a lot of steel, like for the balconies that are already rusting, and they only use like another type of paint, and then after a while it will be painted and again and again. But with hot dip galvanizing, we just need to check it once in a while. Does it need a little bit of touch-up, or maybe just let it be, because it will still last for a while. And the other one is the environmental impact. With no coating, it has to be replaced again and again and again, because it degrades with the air and the salinity in the air and in water as well. And the other one is paint coating. It's also not as good because it has a lot of VOCs, or volatile organic compounds. It's actually not good for the short term and long term of our health. And it's, for example, like benzene in paints that make glossy paint is actually quite problematic for our health. But with hot dip galvanizing, it has a long lifespan, and it reduces replacements, because usually after 30 years, it could be taken apart again, strip it of all the coating, and regalvanize it again. So practically, it can last for hundreds of years with a little maintenance. Next. And these are the key findings based on the quantity. On the quantity, for example, with no coating, it has 0 thickness in millimeters, and then with a corrosion rate of 0.1 millimeters per year. It has a lifespan of 10 years, but it's only on the steel, because after 10 years, it will usually disintegrate into rust. But with paint coating, it has around 0.35 millimeters of thickness on it. And with a corrosion rate of 0.03, it will rust in around 10 years. But that's only the paint coating on it. So if it's with steel as well, it maybe lasts around 20 years before it's already gone. So it's actually not as good as well. And after a few years, it needs to be repainted again. But with hot dip galvanizing, with a coating thickness with only 0.15 millimeters, it has a corrosion rate of 0.005 millimeters a year. And with that calculation, it would last at least 30 years before it needs to be replaced again. Next. And these are the finding implications in hot dip galvanizing. There's quite a lot. Maybe it looks a bit similar on some points, but it is also different. For example, in reduction in emissions. Because it does not have to be painted again and again and again, it doesn't have a lot of maintenance that people have to come, paint it again, touch up it again, but just leave it alone and it will stay. And the other side is recyclability. Zinc is in abundance. And with hot dip galvanizing, 99% could be recycled. Because of from the zinc and its byproducts, like the ashes or maybe the zinc that cannot be operated anymore, and even in the pre-treatment area where we need to clean the metals. So all the chemicals could be utilized for different things again. And the other one is a sustainable practice. It is very sustainable in the long run because, like I said, it doesn't have to be maintained a lot. It doesn't have to be replaced a lot as well. And the other one is integration with LCD goals. Because with galvanized steel, it's actually important for infrastructure. It is already common in Germany where a lot of infrastructure is built with hot dip galvanized steel. Rather than in Indonesia, that's usually not galvanized or maybe just painted. For example, those hot dip galvanized steel beams that's usually inside cement. If it's not hot dip galvanized, usually it will rust because of the acidity inside the cement. But with hot dip galvanizing, it will last a lot longer. And the other one is environmental impacts. Because zinc is not poisonous, it is in abundance. And it's also quite nice because it reduces replacement as well. So for the environment, it's actually quite fine. And the next one is adoption of best practices. As a company that produces infrastructure, for example, building buildings or maybe small items like balconies or maybe just in cars as well. They need to check which types of corrosive protection are the best for them. And for infrastructure, hot dip galvanizing, it has a really nice thickness to it, around 150 millimeters, just a little bit more and a little bit less, instead of, for example, electroplated steel that's only around 8 to 10 micrometers. And its longevity, it's also quite durable for hot dip galvanized steel to be used compared to other protection method for steel, for example, like I said, painting. But it's also quite important with public awareness. In Germany, it's already quite common. But why is it not as common in Indonesia? And that we have to answer it with the next slide, as the challenges and limitations in the industry. Like I said, the first one is public awareness. No one really knows what hot dip galvanizing is. All of them know, maybe just let it be, or maybe let's just use paint. That's quite fine. But if the public know how durable it is, how environmentally friendly it is, how sustainable it is, it's actually a nice idea to start using hot dip galvanized steel for all the new infrastructures in Indonesia. And the second one is high initial cost. Because in hot dip galvanizing, we use liquid zinc that has to be heated over and over and over. It is actually quite expensive, especially in Indonesia, as building the factory to produce the hot dip galvanized steel is still expensive. But still, in the long run, it will be cheaper. And the next one is less profitability in the short term, because hot dip galvanized steel is actually quite expensive to do. Because it's quite expensive, other people, they try to search for other methods. But if we counted how, like painting, it has to be repainted again in 5 to 10 years, rather than hot dip galvanized, it takes around 30 years to disintegrate. So in the long term, it's actually more profitable for the infrastructure because it doesn't have to be replaced again. This is practically my introduction to hot dip galvanizing, and that is my presentation. Thank you very much.
Thank you, Mr. Permana, for the presentation. If anybody on the audience have some question, whether it is on site or online, please raise your hand. We have one here, probably on the online. Do we have anyone who wanted to ask? We do not. Then please.
So one similarity that hot dip galvanizing, I don't know, whatever, has to just painting some non-galvanized steel is that it's above all like a layer on top of the steel itself. I.e., I guess if you like if you somehow split it in the middle, then there's going to be this like surface that used to be inside that's not really galvanized, I guess. Okay, not relevant to that sentence. I do have a question. Like, so when I went to school, they used these painted steel doors, and you said that they will, well, you just paint it, so it will be last 10 years. Well, in my experience, especially since the doors, so like there's these two sheet things that will close like this, and because of that, the paint just gets removed very quickly, and because of that, it rusts and deforms and just stops functioning all that well in, I don't know how many years, but way less than 10, I'm pretty sure. It's like, how much better is that in that respect? Would it have been were the doors hot dip galvanized? If at all, anyway.
That was a really good question.
Okay, for your first question, I think it was the difference between painting and hot dip galvanized steel, right? Okay, with painting, we just paint only the outside part, and thus the inside part will corrode. But with hot dip galvanized steel, we actually dip it in hot zinc. So it's like putting your finger inside wax. There's like a protective coating on it, but it also goes to the inside. It's like a water bottle. A water bottle that you put water inside, or maybe in the outside as well. It's like there's like a layer of it, like a layer of water. It's the same principle in zinc.
Also, so if you have like this long cylindrical thing that you just want to galvanize and you split it in the middle, like this surface that used to be inside is not going to be the exact same as before it has been galvanized.
With hot dip galvanized, it's actually the part has to be like, there's like a hole to it. Because with the open hole, it has to let the zinc come inside. Because it's not like, if it's like just a rounded object that's doesn't have a hole in it, it's actually quite dangerous if you hot dip galvanize it. That's why if you see like a lot in balconies outside as well, with all the railings, there's actually like a small hole to it. It's the reason why it needs to be inside as well. So it's like a double layer in the inside and the outside as well. And if you cut it, there's types of layers inside the steel as well. And the next one is your question about like the paint and the hot dip galvanized steel on the doors. Yes, with hot dip galvanizing, it's actually quite more durable than that. And because the zinc hits the other zinc as well, it's actually quite more durable as well. But still, because it's like a lifetime problem, usually maybe the door is not quite greatly placed, for example, with the paint. Because there's a certain thickness to it, where we paint, it's more thicker than hot dip galvanized steel. But one method to make it better, as not to be painted as much, is have a method called duplex system. It is where first we hot dip galvanize the steel, and then we put a layer of paint using a powder system, where we put like a powder to it, and then we bake it in the oven, and it will be more durable for the door as well. I think did that answer your question? Super.
Too much, yes. We have one question from online audience, but I think it's already answered. But yeah, could you please explain a bit again the comparison between paint coating and hot dip galvanized coating in terms of corrosion rate? I think it is in your presentation, right?
Yes, in the corrosion rate in my presentation, it's not as full, but there's like a corrosivity rate. For example, there's a C1 or maybe to C5 to CX extreme. It's actually corrosivity rate on which area it's implemented. For example, it is in a temperate room, or maybe it's outside, or maybe it is in a swimming pool, or maybe like offshore boring place, where it has a lot of contact with salt. And with hot-dip galvanized steel, in general, it's also already quite durable. So the corrosion rate on zinc is also quite durable as well, rather than a paint coating. Because a paint coating and zinc, it has a different type of material. I think usually for paint coating, it uses epoxy painting normally. And for hot-dip galvanized steel, it uses zinc.
Yep. Thank you. I hope it answers the question. And please give applause to Mr. Permana once again. Okay. Do still have time for it?
Okay, if there are more questions, you could visit our booth, or maybe you could look up at the website as well, at zincpower.com.
Yeah, unfortunately, due to the time limitation, we cannot continue the question and answer. And please give applause again for Mr. Permana for the good presentation. And we'll continue, to the next presentation, which will be titled Built to Last, Pioneering a Sustainable Transport Infrastructure Framework Towards Carbon Zero in PPP Project in TOD Poris Plawat Case by Danang Desfri Abdillah. Yeah, the stage and time is yours, Pak Danang.
Okay, so there's Corinne, I should share with my own work. Oh, okay, I guess I'm here.
Yeah. I hope you can see the presentation now.
Yes, of course.
Yes, please. Please start.
Thank you very much for the opportunity that has been given to me. First of all, I'm Desri Abdillah. I'm currently studying at one program for Erasmus Mundus Scholarship that is majored in sustainable business construction and management of built environment. And for today, I will present one of my ideas regarding built to last. That is pioneering a sustainable transport infrastructure framework
Yep, thank you, Mr. Abdillah, for the presentation. Please give applause to Mr. Abdillah. For anybody in the audience, whether it is online or on site, who have a question, please raise your hand. Is there anybody online who wanted to ask? Okay, then my question would be about one context. PPP here stands for public-private partnership, for those who wasn't familiar with the terms. My question would be for Pa Danang. I think many of the newer highway construction, toll, Trans Jawa or Trans Sumatra is PPP. Please correct me if I'm wrong. Is it could be comparable? Is it, I mean, comparable for? No. My question would be: is it comparable to the PPP project that was the TOD Poris Pelawat, or is there anybody who already did the study and what was the results then? If there is somebody already did the study.
Okay. So basically, I try to focus on the project of transport infrastructure. And we have to underscore, to highlight actually, the difference between highway project and also PPP project. Because we know that PPP project itself, there are two key components, I mean solicited and unsolicited. Mostly, as I know, highway project, PPP project of highway, mostly implement unsolicited projects. And it's different from the PPP project of TOD Poris Pelawat, which is 100% proposed by the government. So, in terms of the feasibility study, we are still collecting of how to, how to use the advancement of technology, how to use how to create the risk assessment, whether to prevent any, to mitigate any disaster, how to make, how to create a building that can open or open for small, medium enterprise or something like that. It's a little bit different between solicited and unsolicited.
Yeah, thank you for the explanation. I didn't know that most of the highway project was unsolicited, but thank you. There is actually one question from the on-site participant. Please, you have 1 minute to explain your.
Okay, thank you so much. As we know, there are several schemes about PPP fund scheme to infrastructure project. We know that build, operate, transfer, then build, transfer, operate. To this TOD project, is this a BOT or BTO? Then the second one, we know that transit-oriented development will increase the land value. So that's why one of the fund scheme to build the transit-oriented development, because the land value of around the transit area. So I think, is it the part of public-private partnership fund, or is it another one?
Yeah, separate,
Yes.
separate project. Yes.
Yes.
Yeah. Thank you for the question. Please. Yeah. Thank you for the question and answer session for Mr. Danang. Once again, please give applause to Pak Danang for the presentation. And now we'll come to the next presentation, which will be titled The Culture of Waste Burning in Kangkung District, Challenges and Solution Towards Low Carbon Development, that would be given by Hadiadani Satria. Mr. Satria, if you are ready, and we need to, yes, but first we need to, can you see the presentations? I hope that you could see the presentations now. Is it visible in your side, the presentation?
Yes.
Okay, wait. I hope it's
Can audience see my presentation, my slide?
yes, we do.
Okay.
Please, the time and place is yours.
Okay, thank you. Good morning and good afternoon, everyone. Thank you, Mr. Zulfikar, for the opportunity and chance. My name is Hadiadani Satria. I'm representing of PT Agro Inovasi Pertanian. Now I come from Majemukut village, rural areas in central Java. In the village
Apologies, Pak Dani. Your slide wasn't full screen. Could you please do the slideshow and make it full screen?
Oh, okay.
Yes. Thank you.
The slideshow play.
Yes. Yes. Please continue. Thank you.
Okay. Then the challenges of creating local development in country industry require a collaborative cross-sectoral approach involving the government, community, and private sector like the variable. And then the negative of coding persists due to limited infrastructure in the past and changing this structure requires socialization, education, as well as support from community leaders and stricter government regulation. Okay, that's the final slide. This conclusion. Bumdes Waste Management and PT Variable Transportation are currently the frontline initiatives in realizing low carbon development in country industry. It is essential to implement Bumdes Waste Management in all villages in country industry to minimize the culture of burning trash. Okay, so that's all for my presentation. Okay, thanks
Yep.
for your attention.
Thank you very much for the presentation. Mr. Satria, is there any question from the audience, especially on the on-site or from the online participants? Do we have from online? Then I would ask one question, Pa Satria. I think the initiative is really, really great. I saw one of similar example, but it was in Yogyakarta. I think it was in Sleman or in Bantul. I forgot the exact place, but I think it was viral a couple years ago. And my question for that and for this is, apart from building or, making the BUMDes, I think the PT Varigrow Inovasi Pertanian is one of the BUMDes, as you mentioned. Is there any concerted effort as well to incorporate or to try to change the culture by means of doing a school roadshow probably, or most also probably from changing the regulation, the local village regulation? Is there any solution or probably what was already done by the, not only the company but also the village to change the culture in the means of that two aspect that I mentioned?
Oh, okay. About the changing the culture is it's not easy because
Yes.
Community habits
Yeah.
this thing was burning is not perceived as harmful. They think burning trash is not harmful, so they didn't want to the village with BUMDes. So the BUMDes in Kapung district have 15 village, and the village have
Yep. Thank you for the explanation, Pak Danny. We actually still have one question from the online audience. Mr. Tanjung, please.
Okay. Thank you for giving me opportunity to ask in today's session. I have a question about the journey Mr. Dani in creative renewable information pertanian. I want to ask about the litigation action that you have already faced in long-term sustainability, and is it possible to have any collaboration with others, and then what is the big difference on your own journey? Thank you. As my experience, the biggest limitation from the variable is still the manpower one. Our manpower still very low. We just have 3 employees for operating this company. So from the manpower is it biggest limitation to give socialization to other villages. And then then we open to all collaboration to until from the other village. Maybe if you want to collaborate with us, we can open with it.
Yeah, thank you. Thank you for the discussion. Mr. Tanjung maybe could ask Pak Haryadani directly in in later time. Yeah, please give applause once again for Pak Haryadani for the presentation. Thank you for the presentation. And let's move into the penultimate presentation of today's session, which would be called Biocharcoal from Community Household Waste around Pusri Factories. Will be given by Pak Danang Trayas Rindra. Oh, is it only video? Okay, then we'll see the video together.
Waktu saya masih di Komisi 7 DPR, saya membentuk panja 9 danau. Itu masalah kami dan saat ini itu adalah eceng gondok.
Waste in the environment is a problem and a burden for the community and also for the industry, especially water hyacinth that grows around the Musi River is the best and most facility. In addition, we have other problems, and that is household waste that burdens the collection and transportation process to landfills. The circular economy concept is a solution to overcome the waste issue and empower the community's economy. The Bible team is responding to this challenge by processing organic waste into biomass to be used as a renewable energy. Biomass is processed by shredding waste and degrading garbage through bio-drying techniques with the help of aerobic bacterial catalyst for 4 days. This process turns organic waste into chips that are ready to be blended. Dry biomass is then blended into glycol pellets that can be used for furnaces and cutting stations. Glycol that are made from water hyacinths and dried leaves have high calorific value and are within the combustion rate for a single power plant. The glycol team conducted comparative studies, learning simulation, and finally has implemented glycol-2024 disrupting the SDG factory operational process. Glycol use is also more economical compared to the current coal price. The spirit of empowering the circular economy for the surrounding community of renewable technology is a mandate that we must uphold for the earth and the future of our grandchildren.
Thank you. It was a really nice presentation. So essentially, the presenter was making a biocharcoal, or in Bahasa Indonesia, arang, from the organic waste around the industries, in especially Pusri, which I think located in Palembang. Is the presenter at the online session? Okay. So if anybody wanted to, yeah, thank you. Do you want to add something?
Yeah, I think I already submit my slide presentation as
Okay.
well. Maybe you can show it to me. Sorry.
Okay, let us check.
Uh-huh. It's okay. If you don't have it, I can.
We do have the presentation.
Briefly.
Apologies for the delay.
It's all right.
Could you please share the screen? Because I think, now it works now. Sorry, the loading was a bit longer. Please, the time is yours for the presentation.
Okay. Thank you so much. Good morning, everyone in Dutchland, and good afternoon for everyone in Indonesia. Allow me to introduce myself. My name is Danang Praisindra. I come from PT Pusri in Palembang. I would like to present about biocarcoal we made from community household wastes around Pusri factories. So to introduce, can you put the next slide, please? Yeah, for introduction, us in PT Pupuk Sriwijaya, hereafter we will call it Pusri, is an Indonesian fertilizer company, a subsidiary of Pupuk Indonesia Persero, located in Palembang in South Sumatra. The company itself is located near the Musi River, and we utilize Musi River water for various purposes, usually for the utility factory, for cooling the machine around the Pusri factories. The Musi River itself is right now is tackled with issue of shallowing. It is caused by several issues, and one of them is by the growth of the the path. It's called water hyacinth, and it's already growing along its riverbank. Additionally, dried leaves are so abundant in our household communities. We have other problems such as cost of transporting waste to landfills, approximately around 360 tons per year, totaling around 36 million annually. The transportation also contributes to its CO2 emission as well. Next slide, please. So, according to Indonesian Ministry of Environment Law number 12 in 2023, biomass can be used for various purposes, and it's already regulated with the laws for co-firing purposes. So, Pusri right now, through the creating shared value, we will call it CSV, is committed to utilize biomass, which is why we want to empower local communities around people inside the Musi River to make up co-firing for SDG power plant through our CSP. Next slide, please. So our methods of making biomass, biocarcoal, is consists of biomass and coal dust recovery aggregation, which we collect from the local communities through our circular economy. And also we have the enumeration and weighing of the biocarcoal. Usually 3 tons of these wastes will make up around 1 tons of biochar. Also, biodairying, which consists of biofermentation and drying process, is one of the key components to make up of this biochar. Biochar pellet casting is then made to make sure that we have the intended hard group index we want. Also, it gives us the benefit of increasing the calorific value. And after that, we use the laboratory analysis to make sure that our calorific value is more than 4,000 kilocalorie per kilogram for co-firing purposes in our steam turbine generator power plants. Besides that, the GCP below 4,000 kilocalorie per kilogram is used for household furnaces. Also, we use it for gasifier in electric charging station that we give to the local communities around pusri factories. Next slide, please. Pardon, next slide, please.
Next slide. Next slide.
Yeah, this is one of the methods that I have mentioned before. Usually it takes up around 3 days for the bioplant fermentation process, and in total we have like 5 days for the total production for this biochar. Next slide, please. Okay, this is one of the examples of the local communities that made this biochar, usually made by aggregating the water hyacinth from the Musi River and also takes up the dried leaves. We usually use the leaves only for the water hyacinth because it gives us the lowest moisture among all. Next slide, please. This is one of the key methods that we use in the process is the laboratory analysis. We have to make sure that the GCP or the calorific value is above 4,000 kilocarb per kilograms. And next slide, please. Okay, so this is the results of the biochar we made. As you can see, we made a pellet of this biochar and we use it as a household furnaces for the GCP less than 4,000 kilocarb per kilograms. And next slide, please. And this is one of the example for the gasifier electric charging station we use. Previous slide, please. This is one of the example of the electric charging station we give to the local fishermen. So we basically give them a gassy electric charging station, and after that we also have the STG power plant in the next slide for the factories. And next slide, please, because we have time's up for discussion. So to conclude, I would like to say that we have made little less impact, but we still have impact that we make. We make usage of 1% in our production facility using this biochar, and we save around 244,800,000 rupiah per year. And we will continue to empower by maximizing our output capacity by this pulverized coal STG power plant by 5%. And we also the first fertilizer company in Indonesia to utilize biomass made from agricultural residues for co-firing in our STG power plant. I think that's all for my presentation. Thank you all.
Yep. Thank you, Pak Danang, for the presentation. For those participants either on-site or online, if anybody have a question, please do raise your hand. We have room for one question. Anybody on site or anybody online? Is there anybody? I do not think so. So probably my question on this is, do the Pusri have planned now to expand, in a sense, the effort to produce the biocharcoal into a economically feasible venture?
Yeah, that's a very nice question. Actually, in our uh, example, in our community, most of the people cut down woods, and the residue of woods is gathered, aggregated, and made into pellet woods that's being exported into Australia, Korea, and Japan. It's one of these countries that was influenced by the Dutchland because they use biomass power generator made from the wood charcoal. And Indonesia, basically, we in Pusri doesn't have a very good opportunity or option by using this wood pellets or wood dust, because the price itself is quite almost the same with the current the current coal. So we think about using this biocarcoal because these agricultural residues we found in the Musi River has quite the high calorific value. So we combine them with the coal dust we had in Pusri factories, 50 and 50 percentage between the coal dust and the water hyacinth and dried leaf residues. And we have found that this 4,000 calorific value, above 4,000 calorific value is quite good enough to be used. Also, we intend to extend the usage from 1% to 5%, and we will also push other fertilizer companies to replicate what we have done, maybe our circular economy concept, so it can be replicated to other fertilizer company as well.
Yeah, thank you. I hope that the venture will go well in the future. Thank you once again for Pak Danang for the presentation. Please give applause. And now we will come to the last presentation of the session, which will be titled Energy Independent Pollution Free Cities, an Urban Development Model that Integrates Filtration Systems, which will be given by Pak Muhammad Fahri Mulia Tanjung. We need to prepare these slides, I think. Oh, you okay? If you could share the slides, Pak, please.
Yeah, we can share the slide. Wait a minute, please. Okay, my friends called Muhammad Zaki Al-Faristi will share the presentation with the host.
Yeah, we will still wait. The presentation is not visible yet.
Can you give the access to Muhammad Zaki Al-Faristi? Because he will be share the presentation.
Which one?
Muhammad Zaki Al-Faristi, one of my colleagues.
I think. Do you need to give the access to share? I do not think, right? Okay.
Yeah. I need the access to share.
Yes. Please.
Okay, we will try in a minute, and we will present our idea for 5%. So, yeah, okay.
First of all, are you guys have seen my presentation?
Yeah, we can see it. Okay, we'll start.
Hey Siri.
Assalamualaikum and good afternoon, everyone. It's a pleasure to be presenting at this 5th International Conference of Integrated Intellectual Community. My name is Muhammad Fahri Mulia Tanjung, and my team are Edi Mustafa Yulianto, Alfianto Nugroho, Langit Lintang Rajendra, and Muhammad Zaki Al-Faristi. We are joined by our fellow undergraduate students from Universitas Gadjah Mada. We are excited to share our concept, energy independent, pollution-free cities, and urban development model that integrates filtration system. This innovative approach aims to address the critical challenge of energy sustainability and pollution in urban environments, with a particular focus on Indonesia. we like to extend our sincere gratitude to our institution, Universitas Gadjah Mada, for their support in this research. We are also thankful to Directorat Belmawa for making this concept a reality and to all our supporters. Indonesia is a country that has great potential to become a developed and prosperous country with abundant natural, human, and cultural resources. However, Indonesia also faces many problems and challenges that hinder progress and prosperity, one of which is pollution and energy. Energy is needed for various functions such as industry, agriculture, trade, transportation, and others. Therefore, energy is essential for the progress of a country. Based on data from the Minister of Energy and Mineral Resources, fossil energy, especially petroleum, is still Indonesia's main energy source, which will reach 31.6% of the national energy mix in 2023. Unsustainable urban development has exacerbated environmental challenges, particularly in Indonesia. Excessive reliance on fossil fuels has contributed to global warming, air pollution, and health risks. The release of greenhouse gases from fossil fuel combustion traps heat in the atmosphere, leading to rising temperatures and climate change. Air pollution resulting from the emission of harmful pollutants poses severe health consequences for humans, including respiratory disease, cardiovascular problems, and increased mortality rates. Additionally, inadequate waste management practice, such as open dumping and uncontrolled incineration, have degraded the environment, contributing to pollution, soil contamination, and the release of harmful gases.
Our solution is to develop energy-independent, pollution-free cities by leveraging clean, local energy sources and aiming for net zero emission. We propose utilizing a variety of renewable energy technologies, such as solar panels, wind turbine, and micro-hydro systems. By integrating the technology with smart infrastructure, we can create more efficient and sustainable urban environments. This will not only generate clean energy, but also improve the quality of life for urban residents. Either the smart filter industry is a concrete example of this problem. Our innovation, which we call IDER, is a smart filter specifically designed for industrial cleaning. This filter uses Jatropha multibidalin plants impregnated with zeolite and activated carbon as natural absorbents. This combination of materials has proven effective in absorbing major pollutants such as carbon monoxide, sulfur dioxide, and nitrogen dioxide. We have conducted a trial of the IDER prototype at TPS 3R Geraha Karagrafika Faculty of Engineering Universitas Gadjah Mada on July 2024. The results were very encouraging. For carbon monoxide, our filter managed to reduce pollutants by 94 until 96%. For sulfur dioxide, there was a decrease of more than 56 until 6%. And for nitrogen dioxide, pollutants were reduced by 40 until 48%. These results show that IDER is able to work effectively in reducing pollutant emission, much better than conventional filter. IDER is also equipped with IoT and AI technology for real-time monitoring and automatic control. IoT sensor detect pollutant levels before and after filtration, and this data is then analyzed by the AI system to provide feedback that helps optimize filter performance continuously. With IDER, we hope to provide a real solution to reduce industrial air pollution, improve air quality, and support global effort to achieve environmental sustainability. We believe this technology can inspire further innovation in the industrial sector.
Okay,
the Internet of Things is a crucial component of our urban development model, enabling seamless integration and communication between various smart technologies. IoT follows a real-time monitoring and management, enabling quick response to any change or issues, which is crucial for maintaining energy independence and minimizing pollution. For example, smart waste management system can optimize collection routes and reduce emissions, contributing to cleaner cities.
Artificial intelligence is integral to managing these interconnected systems. AI algorithms analyze data from IoT devices to optimize energy consumption and predict maintenance needs. In waste management, AI can identify patterns in waste generation and improve recycling processes. AI-driven feedback loops continuously improve system performance, ensuring that energy use and emission are minimized. This intelligent management leads to more resilient and adaptive urban systems.
A significant aspect of our pollution reduction strategy is an advanced filtration system for industrial emission. This system detects and measures pollutants in real time using IoT sensors. Eco-friendly adsorbents such as Jatropha multivinyl plants, zeolites, and activated charcoal are employed to absorb and decompose harmful pollutants. By applying this technology to industrial plants, we can significantly reduce the environmental impact of industrial emissions. The project involves a multi-phase plan to develop and manage an energy-independent, pollution-free city over a 14-year period. The first phase, years 1 until 2, focused on conducting a feasibility study to analyze technical, economic, social, and environmental aspects. In the next phase, years 3 until 4, a natural filtration system will be implemented in industrial plants to reduce emission and produce renewable energy. Following that, years 5 until 7, various renewable energy sources like solar, wind, and biomass will be utilized to meet the city's energy needs. The fourth phase, years 8 until 10, will involve integrating smart technologies such as IoT and AI to optimize energy and environmental management. In the fifth phase, years 11 until 13, sustainable infrastructure will be built to support urban activity and mobility. Finally, from year 14 onwards, the city will be managed with a focus on sustainability, stakeholder collaboration, and continuous monitoring to ensure effective and efficient operation.
In conclusion, the integration of renewable energy, IoT, and AI can transform our cities into energy-independent and pollution-free environments. This approach not only supports Indonesia's sustainable development goals, but also offers a blueprint for urban areas worldwide. By harnessing these technologies, we can create cleaner, healthier cities and improve the quality of life for all residents. Thank you for your attention. We are happy to answer any question you may have.
Thank you for the presentation. It was a great team effort. For anybody in the audience who have the questions, whether it is on site, we have one here. And what about the online participants? Do we have any questions from there? No, then we have one question from the on-site participants.
Okay, thank you so much for the amazing presentation. So probably my question is, what are the limitations or probably the biggest challenge that could possibly occur if we would like to implement this research? And can I have this another question, like two questions? And the other one is, which city that has the biggest potential to implement this research or project? Thank you so much for the questions.
Okay, thank you for giving us a question. First, we will try to answer about the biggest difficult or limitation about our concept. First, in realizing this concept, we need to collaborate, not only us as an engineer, because we have a background in that case, or we are an integrated, we at an intellectual aspect, but we also need collaboration from the government, and then we need the collaboration with the citizen, and we need to collaboration also with the politician. And then with all this collaboration, we can make the concept and trust from the citizen that this is maybe a long-term low carbon development, but it can be realized when we trust on the progress. And I think for the potential city, we have a new capacity. As we know, Indonesia has launched that we will move the capital city, and with this start, we can move to a new low carbon development, a new smart city, and this will be applicable and giving another city to adjusting for the new capital city, and like smart transportation, smart grids, and also about the clean renewable energy in that location.
Yeah, I hope that answers the questions. And thank you once again for the question and answer session for the team, and give applause to the team for the effort. And before I've said that this was the last presentation, but it turns out that the missing presenters has now come with us, not on site, but online. So Victoria Utomo will present her presentation titled Integrated Waste Management Solution for Urban Areas in Indonesia. And for Ms. Utomo, time and place is yours.
Hi everyone. So I'm going to share my screen now.
Yes, please.
Okay.
If it's possible, do please also share your camera or turn on your
Okay,
camera.
sorry. Wait a
Thank
second.
you.
Okay, can you see my camera right now?
Yes, yes.
Okay, now I'm gonna try to share my screen. Okay, can everyone maybe see my screen for now?
Yes, it is full screen now. The time and stage is yours.
Okay, thank you so much. Hi, so my name is Victoria, and I am currently a master's student from FAU studying industrial engineering. So today I'm going to present my abstract with the title of Indonesia's Climate Resilience and Adaptation Strategies for Agriculture Industry in Rural Areas. So I really love Indonesia. Indonesia is my home country, and one of the things that I really love about Indonesia is about how green it is. So it has one of the biggest rainforests in Southeast Asia. And coming from a small village myself, when I was a little kid, I saw like a lot of different greeneries. I saw rice paddies, I saw mountains with a lot of different trees in it. And by the time that I was grown up, and last time when I come back to Indonesia, a lot of things has changed, especially like in the greenery areas, because a lot of different buildings has been created for livelihoods of people. And recently, like there's a lot of media, for example, like Jakarta being one of the most polluted cities in Indonesia, and a lot of different problems because of the carbon emissions. For example, the media said that the increase of greenhouse gas emissions since 1990 in Indonesia has been increasing to 330%. And the ways or practices to be able to mitigate these problems has been practically insufficient in Indonesia. So based on the numbers, in 2021 itself, Indonesia's greenhouse gas emissions only in the agricultural sector has been around 154.16 million metric tons, which is carbon dioxide equivalent. And in total, Indonesia has been one of the most largest emitters of greenhouse gases in the world. So here, like as you can see, like in 1960 until 2022, the fossil emissions in Indonesia has been quite increased significantly, and it would go on like quite significantly in the next few years as well. So what does these things have to do with the climate change? The climate change is one of also like kind of the main causes of the emission problems. So the effects of the climate change in agricultural industry, it has increased the magnitude and frequency of natural disasters, such as floods and droughts, that is interfering with the food production. And especially in the long term, it can also interfere with the water availability and the farm management as well. So there are different types of carbon dioxide sources in the agricultural sector. They are divided into two types, the indirect sources and the direct sources. For example, for the direct ones are the manure management, the water management from the agricultural or production of food. And the indirect ones are, for example, production of agricultural inputs, fossil fuels and machinery, and the energy used for irrigation. The challenge that Indonesia has, or I think in general a lot of the world is having, is that there's a very high demand of a very high population, which also leads to a higher demand for food, for resources, for emissions. But at the same time, there's not enough resources, land, crop yields, or food to be able to serve those demands that the people are having. So because of those challenges, there are some expected problems that are coming. For example, food security, hunger, because there's a lot of populations, and because of different disasters and agricultural problems, there is not enough demand to be able to give everyone the resources that they need, some health problems, and also climate risks such as natural disasters. The ones that are severely impacted by these problems or climate change are the low-income people, and in the case of Indonesia, most of the people with low incomes are living in rural areas such as farmers, and the challenges that they have is that in farming they have low education and also limited financial capacities. So low education means that they don't really have the resource or the finance to be able to go to university or to be able to learn about the impacts of climate change and how are their practices going to be able to affect like the climate change, how is the prediction for the climate to be able to have like an effective farm and agriculture management, and also the limits of financial capacities to be able to use technological advancements that are going to be able to help with the reducing of emission technologies, and some of the government supports are not really enough to help like with the farmers' challenges. The problems that they have as well with climate changes are because of the increasing temperatures and reduced rainfall. There is water availability that is very low to be able to produce the agriculture, and also the increase of significant sickness, pests, and diseases. So the government solution has two types for the agriculture and climate change problems. It is mitigation and adaptation strategies. We are focusing first on the adaptation strategies, but I will be explaining both of them in the next slides. So first of all, adaptation. The definition of it is the ability of a group of people or the community to be able to adapt, respond, and adjust to the changes of a specific situation. And in this case, it is the climate changes and the climate variables. So possible solutions that the people in Indonesia can use is agricultural diversification and agricultural intensification. So for agricultural diversifications, one example is to do research on plant varieties and to be able to kind of add and kind of change like the tolerance of the plant varieties that are more tolerant towards natural disasters, and in this case it's water stress that will increase within the climate change, which can lead to reduce of the loss of crop failure in the land farms. And then agricultural intensification is the practice to maintain the crop productivity. In such cases is to improve the water availability and the crop management practices, so it could obtain optimum growth of the plants. And some examples for that is to build irrigation channels, maintain water availability, and soil conservation efforts. Mitigation, its definition is to reduce something harmful that has occurred or the reduction of its harmful effects. It kind of has the meaning to like practices or measures to reduce the harmful effects of hazards that remain in potential, or to kind of manage the incidents that are harmful for the environment that has already occurred. And some examples for this is to build dams and flood prevention infrastructure and reclamation of inundated areas. So this is something that the government has to kind of develop on. And both of these methods are kind of used in the farm level one. So the recommendation for the farm level to address the barriers, for example, for the farmers, is to enhance the capacity building for the farmers, for them to get like the knowledge and education that they needed, and to also increase the financial support for the sustainable practices that the farmers need to use. So as everyone knows, Java Island is one of the most overpopulated islands in Indonesia, because most of the industrial and agricultural sectors are all there in Java. And yeah, 60% of the agricultural sectors are all coming from Java. And there's this one research in one of the parts in central Java, which is called the city of Kebumen, which is one of the productive agricultural areas in Indonesia. The agricultural production there comprises of 53% area for agriculture, 31% is for wetland, and 22% is for dryland. And other than that, it is also strongly affected due to climate changes, which means they often had natural disasters such as floods and drought that is leading to their crop failures and also water scarcity. And the things that the government has been trying to do in Kebumen is to do what is explained before: the agricultural diversification, the agricultural intensification, and socioeconomic adaptation. And one of the things that is done in Kebumen is also to create this farmers association, where farmers can learn from other farmers and to gain knowledge and also exchange their experiences, how to mitigate some of the natural disasters or some of the problems that they have in their crops. And in the result, or in the conclusion, is that the increase of farmers' knowledge is very, very important, and also their technological know-how to use technology that is going to reduce the greenhouse gas emissions and sustainable practices for climate change, and to develop an effective adaptation and mitigation efforts and constructing a climate resilient infrastructure in the agricultural sector. So that is all that I have for today. So thank you so much for everyone who is listening to the presentation, and I hope you have a really nice day and the rest of the ICONIC event. Thank you so much.
Thank you for the presentation, Ms. Utomo. It was a really nice overview over the issues of climate change and its effect in Indonesia. Please, if the participants on site or online have a questions, please do ask or raise your hand. If not, then I have one short, small question. As as the part of the future generation, do you think that the government of Indonesia, at least, or probably the local government back in your home city, needs to not only aware but also address the climate change issue as soon as possible? She's gone, right? Okay, then then I will I will stop my question here because she's gone, unfortunately. So we come to the end of our session of LCD for the built environment. But before we end the session, I have 3 points to remarks. The first one is the closing remarks from me, that from the 13 presentation, 4 of those are online and 9 were virtual. I learned a lot, especially about sustainability, local consideration in terms of doing the sustainability, putting innovative and inclusion of the technology into the solution. There is also a talk about alternate sustainable sources. We need to also change the regulation in terms not only on the planning terms, but also to open funding line to make the infrastructure project much more easier to conduct. And also, but not least, we also need some local community initiative like the BUMDES in Kendal. And lastly, from the UGM team has showed, we need also those in the future to have forward thinking and designed. I hope that could be also put later into the documents of the ICONIC 2024 as one of the concluding remarks on this session. And the second point that I wanted to say is I would like to say thank you for those who attend on-site or online, for the presenter on-site and online as well. And as a token of appreciation, let's have a group photo. And I invite everybody online to turn on the camera, and I invite everybody in the on-site as well to come at the front. Yeah, to take a photo. Together we'll take a photo. I don't really know how to do the technicals, but okay. Okay, clear. So the one on site will follow the direction of the camera in front of us, and the one online will get a short cue by me. Come. Let's go. Let's gather at the front. Let's make sure that everybody is in frame. A bit on the right, I guess. Okay. On my cue, 1, 2, 3. On my cue again, 1, 2, 3. And last one, 1, 2, 3. Thank you. Yeah, it was a good session for all of you. I apologize for any inconvenience and any delay that was caused, especially by me. And I will give the baton to the Master of Ceremonies again, Mr. Sagala. Thank you, and have a good day.
Okay, thank you so much for your your time, Mr. Zul. And after this, we will have we can have our lunch at the foyer. And those for you who want to get having kind of Friday prayings, you can also meeting in the foyer at 1:30. And that's for all for the ICONIC 2024 conferences, scientific conferences. Thank you for all of those contributions, and see you for another occasion. See you. Bye.
Recording stopped.